Okay, so let's go through this question. We need to create plus 202 out of binary numbers. So we know binary goes 256, 128, 64, 32, 16, 8, 4, 2, 1, and then your decimals. So from 202 we can take 128, so that gives us 128, and we still need an extra 74 to make 202. So we'll take another 64, so plus 64, and we still need 10. So we won't take 32, we won't take 16, we'll take 8, plus 8, and then we'll take, not 4, but we'll take 2, and that, if we add that up, will give us plus 202. Now, since we're doing normalized, we need the two most significant bits to be different. So we'll put 0 for the 256 bit, and then we'll put 1 for the 128 bit. And then we need a 64, so 64, no 32, no 16, we need an 8, no 4, and we need a 2, and no 0. We'll put the 1, no 1, so we'll put a 0 for the 1 there, and so on. We'll remove that later though. Now we need to work on the exponent. Currently, the decimal point would be placed here. We need to move it across to after the 1. Since we don't have any decimals, we need to move it across here. So that's 1, 2, 3, 4, 5, 6, 7, and 8. So we need our exponent to be 8. So we'll do 0, 0, 0, 0, 1 in the 8 column, and then 0, 0, 0. That's an exponent of 8 and a mantissa of, well, plus 202. I'm just going to remove this working, and then we can remove this extra 0 here since we don't need it. That's the first question done. Part B, now we need to do negative 202. So using 2's complement again, negative 256, then 128, 64, 32, and so on. To create negative 202, we can take negative 256, and then we'll need to add 54 to it to make negative 202. So what we can do is not take 128, not take 64, not take 32. Sorry, no, we will take 32. So then we'll do plus 32. Now we need to do 54, right? So plus 32, so now we still need another 22. So we're going to take a 16 as well. We still need another 6, so we're going to take a 4, and then we're going to take a 2, and then no 1s, no 8s, whatever. So we'll put it into 2's complement, the mantissa, so 1 in the negative 256 column, 0 in the 128 column, 0 in the 64 column, 1 in the 32 column, 1 in the 16 column, 0 in the 8 column, 1 in the 4 column, and 1 in the 2 column, and then the 1 column we'll put there is 0. Now we need to work on the exponent. Currently the decimal point is here. We need to move it across 1, 2, 3, 4, 5, 6, 7, 8. So we need an exponent of 8. Again, that would just be 0, 0, 0, 0, 1, 0, 0, 0 with the 1 in the 8 column. Just going to remove this. I'm going to remove that extra 0 there. And that's the question done. Now in part C, explain why the number is not normalized. So when a number is normalized, the two most significant bits are different from each other. In this scenario, they're the same. They both are 0, 0. So the two most significant bits are not different. Now we need to normalize it. So what we can do is we can make these two bits the most significant bit by simply shifting the decimal point from, shifting the whole number from here, we shift it across. So 1, 2. So now we can just do 0, 1, 1, 1, 1, and fill the rest in with zeros. And then since we've already used 2, we can just take away 2 from the exponent. So currently the exponent is 8 plus 16, which is 24. We need the exponent to be 22. So we'll just do 16 plus 4 plus 2, which will give us 22. So we'll do 0, 0, 0, 1 in the 16 column, 0, 1, 1, 0, the 4 and 2 column. And that is the question answered.